Okay, so I think I posted some things on the course material page or something like that. Have you guys seen it? So you guys don't just go there at all. Yeah, 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 and I think yesterday or something. They have posted the final project you guys will be doing. Last week I went there. Oh, no. I mean, I said before the lecture, probably 1 or 2 days before the lecture, I'll put some things there. Last week I went there before the lecture. I didn't see it. Last week. So I posted the project you guys will be doing, the final project you guys will be doing there, and all the instructions for you to do it. So as I'll be going over this one, uh, I'll be telling you what to do in a project. So I think this one, I told you guys that this one I use the speech commands, right? Data set, the one I told you to download. It's known as I think we did this the last time. We talked about the speech command data set or something like that, right? So for your project, instead of using the speech command data set, so you record your own audio. So it's the same thing, like you are trying to control that motor by saying which words to use. Let me see. Hmm? So I think what I use is forward and backward or something like that, if I can remember. So what words do you guys want to choose? Now understand that you have to record only 1 second. Now I think I've done that already. I think my one is forward and backward or something like that. Reverse. Huh? What? Yeah, I think that would do it. Forward. We did forward and reverse. Yes. So I can play it for you. Clockwise, clockwise, clockwise. So 1 second. Anti-clockwise. That would be more than 1 second. That would be more than 1 second. You can still say it. Okay, so probably right, right. Right, left. Yeah, so only two. So if you say right, then it will move the opposite direction. If you say left, it will move the other direction. So you record right, left, probably 200 or 200, and then you have noise. 200 samples or whatever. So, but the end was when you are uploading, it's only upload like 50 and you say the rest cannot be. I've uploaded over 1 hour. So maybe because you are paid for it. No, I've not paid for it. Why will I pay for it? Nah, I have about 15 over 1 hour of. I think for my edge impulse, the project. So the noise will be 200. Hmm? Can I see? I'm sharing it in the page. Sharing what? The final project. Yeah, yeah, yeah. Data set. So I have one. See, look at the number of hours I have. 1 hour 6 minutes 40 of data, and then I think they have to the training is this number. Have you seen it? Means that- So it means that you can upload as much as you want, right? So if you do that, then after that, one important thing is you must add another class. So these are two classes, left, right. But if you don't add another class, you have an issue like noise or something like that, or silence, so and stuff like that. So noise or silence or whatever you record, and then it will depend on the environment you are in, right? So maybe so if there's no sound, what should happen? And then you must add some kind of background noise and stuff like that. So record just probably where you are doing the right and left. After that, you just record the noise in the background and also add it as a class, probably another 200 or 100 samples. So each sample should be 1 second. I mean, there are a lot of softwares you can use to do that. You can record uh, continuously, like probably forward, 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 and then you load it into the software, and then it will chop it up for you. You will just chop it up. I think there's one. I have some free version. Someone it's called Audacity or something like that. You guys have never used it before.
Tell me what I does it. I tell some people to record voice message from your WhatsApp. In 1 second. One
Huh?
second.
Pardon? Yeah, I mean that one is not bad, right?
I use the same voice, but the pitch will be different.
Yeah, yeah, yeah.
See, I mean, I
So this is the software, the Audacity software. You can start to record, and then after you re- after you record your data, so you say that it will record, and after that you can actually chop it up. Like it's called Audacity.
but say there's more than 2 seconds.
Pardon?
This one is still not.
Yeah, so I'm saying that you can use this one, open this software, start to record, and then continuously say forward and break, forward, break. After that, you just chop it up. Like you just drag the the cursor to where you said forward, and then to another one, and it will just chop it up for you and put it in a folder for you. So you're going to learn how to use the software. It's called Audacity, so and then it's free.
So you're getting to a minute. Once like 50 seconds.
It doesn't matter. I mean, it doesn't matter. Right. So this is what I use for for the I think for the speech command there was no silence in it, so I just recorded 15 minutes of silence in a room, and then I chopped it up
15
into
minutes.
yeah 50 of silence. I just left it on for 15 minutes. So it recorded 15 minutes, and then I chopped it up into 1 second, 1 second, 1 second, 1 second. Then it gave me all this.
And you got 15.
1 second, 1 second.
That's how you can.
It's Audacity, Audacity. Let me see. This is how the icon looks like. So if you see this one. So if you record 50 minutes, then you chop it up into 1 second. So that's a lot of data that you have. Understood? So it means that in the project you'll be in a project report or something like that. You'll be explaining what you are doing. So you must understand what you are doing or what the platform, all the parameters on the platform, and then that's what will come in the exams also. So for each step, you must explain what the parameters mean and stuff like that. It's as simple as that. Which one? I mean, every step you must write what is happening. That's all. Yeah. So like this, you must take screenshots of what you are doing and put it in the report. Right. So you create a project. I think I've done this one already. You create a project, create a new create a new project on your platform, right? And then you go to okay. So here I used forward and backward, and then noise, and then noise. So I have samples for forward, samples for backward, and then I had mine. So once you go to the data acquisition, but you must be careful how you are doing it, right? So once you go to the data acquisition, like you can select to choose individual files or the whole folder, so you can just explore them. And after I did my own, you can see that I had 1 hour 6 minutes and 16 seconds of data, and then I split the data into 80% for training and then 20% for what, testing. So here I might ask you, why do you split the data into two for training and testing, stuff like that. That's why this is coming. And then we did this last semester. So what is the testing data set? What is training data set, right? And then why do you split it into 80/20? I hope you guys know the answers to all of this. So these are the exam questions. So, pardon? Yeah, okay. So it means that just take note of the questions I'm asking now. So for each page, there'll be questions like this. Why is it split into 80% and 30 and 20% for training and testing and stuff like that? Right?
Yes, sir.
So the next one is, so you have to explore your data. You have to explore your data. So this is the raw data, right? So you can see that for silence, you see that it's just a line, right? And then you can see for forward, have you seen how it looks like? And then you can see for backward, it's like backward looks like some two kind of words, back and word. So that's why you can see here there's this for back and then this for word or whatever. Right? So it means that this is what this is what in machine learning, because there are differences in the data, that's why you can actually separate one from the other. From the other, right? If not, if they're all the same, if they're all just one line, it means that you cannot actually separate them, and then you can use machine learning here. But so it means that we are able to use machine learning here because there is some kind of differences in the data, right?
Yes, sir.
Then after you have explored, so you have to include all of this in your report. So after you have done this for the raw data, so this is just the raw data. Right? After you have done that, you create an impulse. I think we did all of this the last time. Create an impulse. So here, when you are creating an impulse, right? There are two choices you have. So you have time series data and then images data. So I'll be asking, which one will you choose? Are you going to choose the time series data or the images or the images? So then I'll ask you, why are you choosing which one? So as I said, these are just the exam questions. So that's why I said I was actually prepared to finish today. So that's just what I'm doing. Right? Huh? Next week I won't be in the country. So all right. So pardon?
Yeah, I hope that. They say the link. I think they are looking at it. I don't understand what this is. They say has downloaded the link that you shared with them.
Yeah. So just pay attention here. Then you can go home and go and try it.
Sir, like this. Pay
What?
attention when you go with your voice, please.
And I said just pay attention here. Then you can go home and go and try it. So everything is in the slide. Everything is actually in the slide.
I'm really confused.
About what?
When I'm seeing or watching videos, that's why I'm asking. I'm asking you, but you say I should pay attention.
I mean, what have you downloaded?
I'll say what I'm not.
This is command is the data set that I use. Sorry, this is one.
This is it.
Data set. This is for the audio files.
So this one is different from the post
This is the audio files, the forward, backward audio files. So you can just extract it. Okay.
I just closed them.
I can just extract it. I don't know why. Okay, so as I said, so here you have to choose one of them, time series or images. So which one will you choose and why?
Time series. Because when I use audio,
So now and after that, once you choose the time series, there will be parameters like the window size. What is the window size? I'll ask that one. There are parameters like window increase. What is window increase? There will be parameters like frequency. What is the frequency? And then there's parameters like zero padded data. Right? And I'll ask why have you checked the zero padded data? Just easy stuff like that.
so for the window size, I know that the duration of the sound.
Yeah, so usually I hear it's 1000 milliseconds, so 1 second.
That's 1 second.
And then the window increases what?
That's the increasing the window increasing
Increasing what?
the sound.
Now, so you see that each sound must be 1 second, right? But what if you give it 2 second sound or 3 second sound or 3 second input? So what it does is that once you give it let's say something that is 2 seconds, right? What it does is that it will first of all pick 1 second, right? Pick 1 second. Then after that, it will increase the window by, it will move here by 500 for 500 milliseconds. And then it will now pick another 1 second. They move 500 milliseconds, right? So it means that you are chopping a large sample into 1 second, 1 second, 1 second by moving each time you move 500 milliseconds. Understood? Okay, so what is happening here is that your inputs, right? The actual, so the window size is the actual duration of data that will be used for your classification. That will be fed into your machine learning algorithm. Is the actual is 1 millisecond. But when you feed it with um, probably 3 seconds data, you know that 3 seconds is more than 1 second, right? So what it will do is that it won't just throw that data away, right? Because it needs 1 second, 1 second, 1 second. It will chop the 3 seconds out into 1 second, 1 second, 1 second. But you have to move, right? So if let's say the data is 1 second like this, from here to here is 3 seconds, right? You have to chop these 3 seconds into 1 second, 1 second, 1 second. So it will first of all pick 1 second. Let's say here's 1 second, right? After that, it will have to move. So the window increases how much to move and now pick another 1 second. So because it has took 1 second from here. And after that, it moves, let's say it will have to move 500 milliseconds and pick another 1 second. And then move another 500 milliseconds and pick another 1 second. So it will chop this up into several 1 second, 1 second, 1 second, 1 second. By moving each step is 500 milliseconds.
So the difference of the step of that 500 seconds.
Yes. Yeah. And then zero padded. You know what that means, right? Padded. Zero pad data. You see that some blue thing is ticked. So you can either tick it or untick it. It's your choice. But if you do that, it has some kind of implications, right? So you know what zero pad is? Eh?
No, sir.
You've never heard of zero pad before.
No, sir.
So now we are talking about 1 second data, right? What if you give it yeah, yeah. Everything has been given to you on the platform, so you guys, everything is given to you. All the slides, all the videos are there for you guys.
Like you did it before.
Yeah. So the zero part. So what if I'm looking for 1 second, right? But I give it like I'm looking for 1000 milliseconds, but I give it 900 milliseconds. 900 milliseconds is less than 1000 milliseconds. So what should it do? It should just pad this with 100 seconds of zeros, like nothing. So it will pad it up and now feed that one to the algorithm, right? Now, if you untick it, and then it sees any data that is less than 100 milliseconds, it will throw it will throw it away. So it has
That's thousand.
yeah, it will just discard it. So that's the implication. So that's why I said each parameter has a meaning, right? Yeah.
Say for the base, as it will come in the examination, will it be, are we going to get objectives?
No, no, I don't know.
Say, I'm sure about professional.
I can't remember whether I said
To
objective.
give us,
So it's down to objectives. I said question.
But then no, it's just they're just simple stuff. So why is it?
you see, the 0.5 this is break,
Yeah, yes, yes.
increase. It's the window increase. Before you know, I might be a bit now above my
You
you
are
understand? So if there is, can just give you a oh
bro,
no, this one.
nah. I mean that is what exam is for. So it means that before you come to the exam, you must read and you must read on the thing. Right now, after you have done that, you add what? Add processing block. So you have gotten your input, you add processing block. So here you know what the you
I wanted to ask the question that Ashley said.
yeah. Which one?
Can I move over? Yes, yes. So assuming we didn't select the time series, or we use the image series, meaning our window
Everything here will change.
is not going to be in time.
Yeah,
It will be in unit size.
like some images, like dimensions. So
Okay.
like how we studied the last time, images 2 by 2 and stuff like that.
Okay.
Then you go to the you must add a processing block. So after you have done with your inputs, you must add a processing block, right? So you know what a processing block is? No. So you have your input, your raw data comes in, your raw audio comes in. You must process that raw data before you can actually feed that raw data to your machine learning algorithm. I think we studied this the last time, right? Or no? Okay. As I said, these are just the exam questions. So what is the processing block and stuff like that, right?
Yes, sir.
So now once you click on the processing block, there are several of them. As you can see here, you have a choice between 1, 2, 3, 4, 5, 6 of them, and then each of them that you choose has implications again, and then it will change your whole. Each of them you choose will change the accuracy of your algorithm, right? So we have one like the MFCC, another one is MFE, spectrogram, audio, or you can also choose to use the raw data. Don't actually do anything to it. Just use the raw data, right? So and I ask you which each of them is. Define the MFCC and stuff like that. Define MFE, define spectrogram, the other one and stuff like that. So you must go and read on them. As easy as that, right? So now if you choose the MFCC, what happens? So and then in your report you must use each of them. So you must choose. Please pay attention here. So that one you must choose one of this and go through the entire process. So if you choose one of them, if you choose the MFCC, you must go through the entire process and get some results, the accuracy, the laws, and stuff like that. And then you come and choose the other one, get all the results, compare all the results, and then you now compare which one gives you the highest accuracy, which one gives you the lowest accuracy. So all of this must be in your report.
The case is not an issue.
Pardon?
The case is not an issue.
Understood?
Yes, sir.
Right. So now here
Yes, yes.
here I'm using so as I said, just go and find the meaning of all of this. All the MFCC, what does it mean, the full meaning, what it means, because that's what I'll be asking you. Right? So after you are done, then you come and add learning block. So you need to add a learning block. You already know this. We went through it the last semester. So you have processed your data, right? So you take your data, you process it and stuff like that. And now you must pass that data through you must design your machine learning algorithm and pass that data through it. It's as easy as that, right? So now which one will you choose? So there are several of them again. So we have classification, regression, transfer learning. So I'll ask you which one is the best for the project or stuff like that.
Classification.
Yeah, it's what and then why? Understood?
Yes, sir.
Right. So now as you choose classification, so now here we have our classification, we have our MFCC, and then we have our output features. So you see that the output features are your outputs, right? So you know that we have three classes: the forward, the backward, and then the silence, right? And then our next one is you just click on save impulse, and then now then you go to the MFCC. So the MFCC has some. So this is what the MFCC will give you. So instead of using the raw data, if you the MFCC is an algorithm that will take the raw data and convert it into images like this, right? So you can see that the first one is silence, right? So now it has picked your time series audio data, and then it has formed a 2 by 2 image. Have you seen it? So you can see that the silence is different from the forward, and then which is also different from what? The backward. Understood? So this is what the MFCC does. It will take your raw data and then give you results like this. Right? The MF will do a different thing, but also give you the results like that. After that, you just click on your save parameters. Have you seen it? Then you generate features. So why are you generating it? What is generate features here? We did this. We did all this last last episode. That was about some 2 months ago. So why are you generating features?
Know the closeness of the various data.
But have you guys seen your results?
Not yet.
I don't have it. No.
In that level.
So why are you saying why do you generate the features here? As I said, these are the exam questions. So don't go and stand anywhere and say that I didn't explain anything, right? So why do you generate the feature? Well, like what is generate features? What is it? From last semester. Hurry up, hurry up, hurry up, hurry up. What is it? What is it?
And I mean,
Generate features. So as I said, I think the last semester I said that for in machine learning, what it's looking for is differences in the patterns of data, right? That's all it's doing. Like it looks through this data and then it sees differences in between them, right? So it means that it will, for instance, for you to design an image classification to identify a human from like a horse, right? The human has some features. Every human has some features, right? So it picks out those features, and then it goes to study the images of the horses. You know that horse still has some kind of features. So it picks these features, and then it will use that features to be able to identify that this is a horse or this is a human, right? So that's what we are doing here. Once you click on generate features, it will generate those kind of features for you, right?
yes, sir.
Then after you've generated the features, you have to explore the features. So this graph is known as the feature explorer. So you can use this graph to see whether your machine learning algorithm will do well or not. Will it be able to separate one class from another? So here you can see that the green one is what? Silence. Have you seen the green data there? The green is silence. The orange one is what? Forward. The blue is what? Backward. So it means that there is so much difference between silence and forward and backwards. So you see that there is a lot of gap between silence and then the other two, right? So it means that the features between silence data and then the other two is just bars. So it will be able to separate silence and then the other two very very well, right? But you see that when it comes to the forward and backward, you see that they are almost together, even though it has been able to separate them, right? But some some of the samples are have crossed over, so it means that those data are very close, right? And I mean, if you see if you see the raw data, it is almost the same, like right. And then I think this looks like forward, and then the backward was this, and then some space stuff like this, right? So they are almost the same, but it has still been able to separate them. So it means that when it comes to classifying forward and backward, it will struggle a bit. Have you seen it? So from here, you can know whether your algorithm will do well or not. Understood? Right. Then your next is the neural network setting, the actual neural network. Right? That's what we did the last time. The network, this network is 1D. It has this number of neurons and stuff like that. Right? But so I'm asking you, what is the training cycles? What's the meaning of training cycles? Right? And I'm asking you, what is the meaning of the learning rate? I think we did this the last time. So all of this, so note those questions down. What is the meaning of training cycle? What is the meaning of learning rate? So go and find the answers to them because we already did it, right? Then our next is, I can't see anything. So this is our neural network architecture, right? And then this, you have the option to choose between a 1D convolution. We did that the last time. Convolution. Right, you have the option to choose between 1D convolution and 2D convolution. So why do you use one? So here we chose 1D convolution. Why did we use 1D convolution? Another question. And then why don't we use 1D convolution for the project? You must know why. Right, and then we have the input layer and then some layers and then the output layer. After that, you just click on start training. Now, after you are finished with training, then you will see that the accuracy and then the loss will come. So I ask you, what is the accuracy, what is the loss, and stuff like that, right? Define accuracy, define loss, stuff like that, right? But you know that we have an unoptimized float 32. I think we did it the last time, float 32 version, and then we have int 8, right? This flow 32 is optimized, this int 8 is optimized, right? So you pass the flow 32 is used for training, the int 8 is used for deploying because you are deploying on a micro what controller, right? Not a PC, right? So it means that you have to make sure that your network is very very small, right? I guess pay attention. Okay, so I'll ask you, what is float 32? What does it even mean? What is int 8? And then how do you convert from float 32 to int 8? Stuff like that. And we did this the last time also. Okay, so now, after that, you can find results like inferencing time. Have you seen the results there? Inferencing time, the peak RAM or something like that, and then the flash usage. Then, okay, this is for the int 8. So you see that the result for the int 8 and then the floated 12 is almost the same. I mean, for the accuracy, almost the same, right? Understood? Okay, now after that, you are done with your training. So if your results is good, if you hit above 90, if you hit below 90, it means that you can't use it anywhere, right? Nowadays, it's always above 95%. If you hit below that, it means that your algorithm is not really that good. So you must go back and go and do some settings to it, then get higher accuracy, right? So you know that we divided our data set into training set and what?
So you test it.
And a test set, right? So we use the training set, the 80% to train, but the test set is reserved. It means that that test set have not been used in the training. So it means that at this time your model is now about to see new data, completely new data it has never seen before. So how will it perform when it sees new data, right? So you pass your test data through it. You just click on classify or and then pass your test data through it, and then you see that after you pass your test data through it, your accuracy has actually reduced to 95%, right? So I'll ask you, why has the accuracy reduced? Right? So is it that why did the accuracy reduce from 98% to 95%? Why? Then you must be able to answer in a long statement, right? Yeah, yeah, yeah. I mean, this is brief, then brief answer. Brief marks. The longer your answer, the more marks you get, right? Okay, then you. Aha. So the most important thing here is the live classification. So here you know our end goal, right? What is our end goal, sir?
Our end
Our end goal.
is to force the motor to go forward.
Aha. But all of this we are doing right now is for the system to be able to pick out your voice and then send that voice to the motor to actually control it.
Yes, sir.
Right? So that's the stage we are. So you can this live classification is not cannot turn the motor on, right? Because we have not done anything to the motor. We are now dealing with the machine learning algorithm, right?
Yes, sir.
So you can just click on your live classification, and then I mean the classification you must go through a lot of steps to be able to accomplish it. Those steps don't matter now. But okay, but there's an easier version of it, right? Where so the live clarification is that you are now connecting the actual board, the board you're going to use, to the PC, and then you're going to use the platform, the edge import platform, to pick some data, and then that data will be sent to the actual board, and then you'll see how your voice work or not, right? So if you say forward, will you be able to send that data to the board to classify and give you some results or not, right?
Yes, sir.
Okay. So it means that at the end of for your project you have to demonstrate that it's working. So you'll be using the live application. I'll bring the board and you use the live application. If it works well, then you get your marks. If not, yeah. Pardon? Yeah, yeah, but they said 11. How many weeks? 2, 3, 1,
Sorry.
3 weeks more. So next week.
Yeah, it is so.
I mean, when does lectures end?
28th of July.
I thought it was 14th July.
So they have revised it.
Ah,
So I've shared the revised one.
okay, okay.
Yeah, everything every 2 days there. So every 2 days there, they are reviewing it.
Okay, so you do your live classification, you pick out, you say some forward, backward, and stuff like that, and then you will see whether it works or not, right?
Yes, sir.
So now your next stage is, then this is the actual. So the actual thing is that you are going to deploy it on your board, on your Arduino board, right? And then you you, you must know the different Arduino boards there are, right? I think the one that is used the most is this one. I think we did this the last time.
Yes.
The Arduino Uno, and then the one we are using is the Arduino what?
DME 333.
Okay, so I'll ask you to give me the difference between the Arduino what?
Say, okay, okay.
With this one is last semester.
And that was last semester. So far.
So give me the difference between the Arduino Uno. This is the Arduino Uno, and then the Arduino 33 Nano BLE Sense. The differences, and then why is it that we can run machine learning algorithm on the Nano 33, and then we cannot run machine learning algorithm on the Uno? These are the questions that will be coming, right?
That's why I answer.
But I hope you guys know why you can run machine learning algorithm on the Nano, and then you cannot run machine learning algorithm on this one.
Because of the memory size.
So what is the memory size of the Nano?
The nano is
I think I got my Nano.
kilobytes.
This one.
Yeah, something kilobytes.
Yeah, this. Pardon?
If you say it's loud, then you said it. And you can say it, everybody heard it.
The other one is 164. This 64. 64.
No. So go and find. Okay, I think the differences are all here. They're all in the slides, right? So you can see that for the flash is where you store the program itself, right? The flash of the Arduino Uno is what?
32 kilobytes.
So only 2 kilobytes. But the flash for the Arduino Nano is what?
1 MB.
So it means that why can't you run machine learning algorithm on the Uno? You guys have seen why, right? The memory it does not have enough memory to be able to run machine learning algorithm. As easy as that, right?
So sir, this one, so we can use those differences for to answer your question.
Yeah. So the question is, the first one would be, what are the main differences between the Uno and then the Nano? So you see, you talk about this flash is one of them is 1 megabyte, the other is what 2 kilobytes. The SRAM is this has SRAM of this one has CPU of this one has CPU of this and stuff like that. After that, why is it that you cannot run machine learning algorithm on the other one? Stuff like that. Then you just answer and then you are done.
Yeah, the way she am.
Yeah.
I mean that.
Oh yeah, if you want to be done.
Thank you.
Right, so now you know that this is a board, right? And then our main, what we are going to use is the mic on the board. This has an integrated mic that will pick your voice and then send it to the algorithm and then it will run and then stuff like that. I think we did all of this the last time, so now the most important thing is that after you have run your algorithm and stuff like that. Now the most important thing is you must run the algorithm on your board. So how are you going to do that? Right? So this is a step where you go to deployment. Have you seen deployment there? So there's another step, deployment. And then here for the deployment step, you have some options, right? Let me see whether I can do it live for you guys. Do you guys have internet here? Internet. Let me see. Okay, let me connect my hotspot. Yeah, yeah.
Then, I mean, hey, sorry. So,
Yeah, yeah.
this, the videos, I'm not getting the current one.
Which current one? I think it's just one video. Yeah. Just one video, just one.
Just one video.
Yeah.
No, but it's not there.
It's not way. We are not in the AI classes. No, no. So this is AI course and we don't do robotics classes, but still go to the exam. Go there, you put and then all the files you see all the files plus the video and they don't connect. So they don't yes,
Very creative. Can video.
yes, yes.
I've seen it.
So pay attention here. So now, so from this, can can you guys see what is wrong with the projector, or is the projector?
The sharpness of the projector has gone.
Okay, let's get on. Okay, so the most what I was talking about is that black, black. Okay, so let's start. Let's continue. Sit down, sit down, sit down. So this is very important. So how are you going to get your code to run on your board, right? That's what we're doing. So you see the deployment here, right?
Yes, sir.
The deployment, right? You go to deployment. Kai. Okay, my internet is not connecting, so okay, let's continue. So the point is that you go to your deployment page, right? And then you search for what type of deployment you want to do, right? So now you can deploy using the Arduino library. That's what you're going to use, right? And then what the Arduino library does is that once you click on once you use this Arduino library, it will generate the model for you, right? And then it will generate some examples also for you, right?
Yes, sir.
So once you use this, you go to build. You go to build, and then so here again there are some parameters here. Once you're about to build it, it will give you some hardware results like the latency, the RAM, the flash. So I'll be asking you questions on that too. For the so the int 8 and then the quantize and then the float 32 have different results. So you must explain why they have different results. Understood?
Yes, sir.
Okay. So
Okay,
now,
so the exams, your questions will be
oh
plenty.
yeah, plenty. So that one a lot, a lot. So now you go to build, and then after you build this one, it will generate a zip file, a zip file for you. You guys know what a zip file is?
Yes. When I have it.
So I can't remember that. So it generates this zip file. So you see the name of the zip file. So the EI and then dash the name you gave it, the name of the project you gave it. So here I use robotic subsystem. So it will generate this EI dash robotic subsystem dash Arduino. Then it gives you the version or something like that, right?
Yes, sir.
Now, if you go into the file, right, you will see some examples codes there. You see the source file and stuff like that, right? Now, when you are done with all of that, right? You have generated a file right now. What do you do with the file? You have generated a
Run it.
file. Eh?
Run it.
How? How do you run it? Very important. So these are the technical questions that will be coming. And then I know that this time the highest mark would be like 50% or something. The last time everybody was getting almost 90. This time I know it will be like 55 or
Say,
Sir, we compile. We compile.
You compare.
We compile.
You compare.
Yes, sir.
You you can increase the highest mark can be about 58. If you don't pay attention, that one the 41. So you have to open your Arduino IDE, right? And then you guys install this thing the last time, right?
Yes, sir. Yes.
Hmm?
That thing I know was something like that.
So you see that you have generated your zip file. Maybe it will come in your downloads, and this is what it looks like. Have you seen it? AI something. But how do you run this one? That's the issue you are facing now. How do you run this AI robotic subsystem 1.0.5, right? So you have to open your Arduino IDE, and then now pay attention how you run it, right? So you see the sketch here. Have you seen it? You can see we have files, edit, sketch, right? So you go to sketch, and then you go to, so now it's a library. You know that the Arduino, as I think the last time I was telling you that the Arduino deal with only it deals with libraries. So you call the library, and then you call some function in the library, and then you write your code for it to work for you. So the file from the agent port also comes like a library, right? So you go to sketch. So you you must include this library in the Arduino system so that they can actually know that it's a library. So you go to sketch, right? Then you go to, have you seen the add files here? Or probably, you go to sketch, include library. Have you seen it? Then because you see that it's a zip file, right? So you go to add zip, and then you navigate to wherever that file is, and then you just double click it. Have you seen the process? Now after you are done that, you will go to files. It will appear in the examples. Go to files, then go to examples, right? Then you just go through and look for the name that you give the project. I think I gave it what, robotic something. If only I've loaded it. So you go to how you name the project. So I named it robotic subsystem influencing. Have you seen it? So now, once the file it gives you, it has made it very easy for you. It gives you some examples to run with. So you go to the board that you are using. You know, what board are you using? Nano 33 BLE sense. So now it gives you some examples. It gives you accelerometer. It gives you camera example. It gives you sensor fusion, and then a microphone example. Have you seen the microphone there? So because we are going to use microphone, we are going to click on the microphone example. Have you seen it? And then it will just generate. It will bring out the codes for how for you to be able to compile, and use the microphone to do live um, inferencing. Have you seen it? So this is the code it generates for you. So I hope you can go through the code line by line and understand whatever it's doing there. So here, oh yeah, nah, it's just very simple. Very, very simple codes that you can easily understand. So here, the most important that but yeah, you are doing programming, so you must understand each line of code, right, and what it's doing. But the most important thing is that you have to compile and upload onto your board and see how it is working first, right? This compilation will take like probably some 20 minutes, maybe, because it's a lot of codes, right? But I think it's going fast. But once you go through the code, you can easily understand what it is doing. And then the most the most important thing is here. See, you just pay attention here. You see that in your code, what we are doing is that so the most important thing is what happens in your loop. Pay attention. The most important thing is what happens in your loop function, right? What happens in your loop function, and then I think at the last time I said that the Arduino code has two functions, right? The-
Two functions.
and then what?
No,
No.
it's
This
a
one here,
setup. The setup
the setup and
The
loop.
And
setup.
the God is the same as the loop. You are completely.
Then now the highest mark has come down to around 45.
it's a setup and loop.
So we have setup and loop, right? So now the main thing is the loop function. So you see that here, what we are doing is that it will first of all print. So if you see AI print, it just printing something on the console. So it's printing start inferencing in 2 seconds. So it picks up samples every 2 seconds, right? And then it will say
I said
record.
the print will be on a setup.
Pardon?
I thought the print will be on setup.
Now here we are printing. You will pick up samples every 2 seconds. So it will do that every two
This will
seconds.
come to the loop.
So it will be in a loop.
It will repeat itself.
Yeah. Oh yeah, we are going to be done around 10.
You are going to class one.
Uh,
Think I'm going to university.
okay, so let's just finish. Let the code finish and then we just go. But I hope you guys understand the code because it will come in the exam. Like each line of code, explain each line of the code. That's why I was saying that. So here it's very simple. So here what you're doing is that you are doing voice, right? So you must record some audio, right? So this function here is a function that will record the audio for you, right? It will record the audio and then it will come and then if it's done, it will say the audio is done, recording done, and then it will come and run. It will send that audio to the classification algorithm that you just did. So you see that here is run classifier, and after that it will just do the prediction. Have you seen it? You see here print. It will do prediction and then it will print it will print the DSP, the number of seconds it used for the DSP. You know what DSP is? So and then the digital signal processing we used was the MFCC because it takes the audio and then passes through some algorithm to process it before it does the classification. So it will print the number of seconds it used to do that kind of processing, and then it prints the number of seconds it used for the actual classification. Right? Have you seen it? Then after that, it will come and print the results for you. Say it will be the results dot classification, and then it will print the label and then the value. So it prints a percentage for you, right? So it prints, let's say, forward is 0.5%, right? Backward is 0 point something percent, and then the other one is what? The silence is 0 point something percent. But you must know that all these percentages must add up to what?
900 or 1. So 100
90.
or 1.
Okay, it will print it in probability. So 0.5 means 50%. So probably 0.5, 0.4, and then 0. What? 1. So all must add up to what? So it means that the highest, because it is printing probabilities, the highest one will be the sound it heard.
Silence for a minute.
Pardon?
So I think the silence will be the one which will be highest.
Yeah, most of the time because once you don't see anything, it will be the silence will be about 0.9%, 0.9%, 0.9%. So you see how easy that is. So if I say explain all the lines of code and how what right? Any question?
Hey, Africa, I want us to code.
Yeah. So any questions so far?
You have any question? You have any question? You have any question? My brother.
Any question?
So you have any question? Joseph.
Okay. So I think this thing will take a long time to compile. So we can close now.
You are close.